Yeah, it is. Could you say it? Are you saying
I like that it says
it?
Macrisma.
Yeah, yeah. I like any other word, so I said, let me use what I see. So here is it's a home place.
Yeah.
So you can see it's a panel, a control panel where you could unlock locked. Okay, funds in a Prisma smart contract.
Okay.
I already did the smart contract. I compiled it to the Plutus. I could show you this. I'll show you the script address later on. Will you hear
Okay.
me?
Yeah.
So it's in a pre-board network. Mostly we are dealing with the Conway because there are errors, different errors. And for Cardano, I noticed the latest one is the Conway, and the contract is the icon, the version 3. So first it starts with a
Yeah.
smart contract where the funds are locked in a script address with some data and redeem. So it's quite a process still there. So the contract checks the scores. Okay, I kept the P's and the D's into an integer for now, but I noticed the P then graph the the participation ones then graph primitives. Hello,
Say that last part
tabs.
again. Hey.
The participation primitives are they in graph?
Yeah.
Okay, then graph
The what?
the participation primitives, the P, the internal.
Yeah.
Yes. So, and the demands for now I've only kept them into integers for for the presentation first. So after the contract, see it does have the P's and the D's. It now releases the order and funds it to your wallet. So first, now we go to the unlock funds. Here you connect your wallet and select your scores, paste the contract down, and everything okay. The signing is done by the wallet. It pops out after submitting the transaction. So let's connect. My tunnel connected as this this test tokens, the adder. So here for
Yeah.
the locked transaction ID, we use the one for the smart contract. The I use transaction output that sits in the smart contract. I do have it on my so I have it is the transaction ID. Let me copy paste it. It is it is in every smart contract it has a transaction. You just paste the transaction ID and you also paste the contract code. There's a contract code and also the voters key hashes. So the voters I kept them because maybe let's say a hub contains maybe 10 people. Obviously for the transaction that they have agreed upon, they should add some they should vote upon it the best. Maybe they could have two of them or three and vote for the one that they see best. So here they provide the voter key hash. I have some of them here. Taking a while as it is. So and now the contribution scores here I place them the total should add up to 10. This is because of the contract. In the smart contract, I have also said that P and D, they should bring a total of 10. So whenever you change the participation and it's greater than 10, it will bring an X. And even it should not be so lesser than it, so it should be actually 10. So you can change it. But for the P's, I know they're in graph form. But the back end, I was thinking maybe we could reduce it to P, the participation primitive. The demand, which is the external, which contains the transactions and the receipts. That's where I did have a question on how maybe we could collect it, but I also made it become an integer. So when I unlock the funds, also the amount is fixed. The amount is fixed because of this. Maybe different hubs they could submit, and the script address maybe have a certain amount of ADA in it. So different people, okay, different hubs will only receive a specific amount. Yeah. So I've already built the spending script. It's building the transaction. It should actually call out my wallet. So it will take a while. Maybe let's say half. I mean, 1 minute and a half. So uh, there it is. It has popped up my wallet. So so here. So for the I have to place my pin for it to sign it. But before I do that, maybe you could see on how the smart contract is the script address. This here it is. So I funded it with 17 others. Here it is. It shows the transaction still sits on it, and it should send 1.6 ADA back. And also in my wallet, I also have a collateral input in case it fails. The fee is cut from the collateral one. You could also add a note for the script address. So it's unsigned. So here's the transaction ID that sits also at the script address. The script address in the smart contract. So back, so I'll sign it with my pin.
Wait, Paul,
And now it's submitted.
is the screen
Yeah,
is the screen still meant to be on the contribution scores?
the screen,
Yeah, the shared.
the screen, or what? It, it could be, or I don't know. It can be, or maybe not.
I mean,
Maybe let me
are
first
you
present it, and
are you
maybe
sharing something else?
if okay, yeah, it can be in the contributions code data.
Okay.
If or maybe I start my own hub, and maybe I don't know. I will think about it. So right, submitting takes a while submitting and calling my wallet, but not that too much time. Maybe let's say yeah, there it is. So the funds unlocked, your wallet signed and submitted the transaction. The other is on its way, and it brings us another transaction ID. You could click and copy it. That's how it is. That's the unlocking funds part. But for now, so after submitting, it goes into a meme pool. It's data chosen and data sent to the on chain.
Okay.
That's
Cool.
the our part. then this is there. Okay, it's the check the blockchain. So here, it pipelines the the different socket addresses for Cardano, the nodes. So we could say now we're in the pre-node, the pre-prod node, and here we could scan for any transactions, any that they are flowing through the Cardano. So after maybe unlocking our funds and sending us the transaction ID, we could search for it over here and to make sure that it was sent on chain. So here, when you scan, you could just paste the slot number in the block hash and how many times you want it to jump forward, roll forward. The maximum I've set it to 50. So it could scan. The transaction will be the more blocks you scan, the more data, but it will become slower a little bit. So it's taking some time. I don't know, it can that much. It will just come later. Maybe you should continue to the third part. I guess after coming back, it will be reading has loaded. Is that fine?
Okay, that's fine.
Okay. So the next one is for the connected hubs. Here, I call it the gossip, where after we have already submitted our spending transaction, we could gossip it around the hubs that we are interconnected with. And after unlocking our funds over here, it automatically fills this with the signed transaction over here. So we'll be sending our transaction across the other hubs. You can send to a specific one and you could set how many times you want it to hop around. Maybe if we are hub A, there's hub B. Hub A could also send to hub C if hub B has some connection with hub C. Yeah, yes, that's the simplest way I could put it. So here you could search how many hubs are connected. I haven't connected with any other person for now, but it connects to this port at TCP, and it will show it will list the members who are present. And also, if you are receiving the gossip from maybe another hub, the message comes automatically here. It checks after every 3 seconds. Over here, it sends. Yeah. So now it won't send because I have not sent. Yeah. So in our chain, it's done.
Hey, that's
So
pretty cool.
handshake protocol. Yeah. Let me try again, please. Let me start it from the beginning. Again. I don't know why it says the handshake was rejected. Let it load a little more. So let's go to the network part. So the network here one could change from pre-prod to mainnet. So for now we're using the pre-prod for now. when we apply it and connect to Cardano. Yeah, it's it for this one, check how heavy it is. So after searching or scanning for the blocks, it sends you the blocks. So I began from the beginning of all transaction in Cardano. You could see it is I jumped 50 blocks to check. So out of 50 blocks, and you could see and the bytes it carries, the slot number and the error that it is. If you want to go further from that, you could just copy the slot number and you just you come over here, just it over there. You also pick the hash of that block, you copy it, and you paste it and you scan. Yes, I will have just kept it to maybe 25 blocks if it's quite huge, but it will just finish for it. Remember the before one was there were 26 transactions, but now there are two. So 50 blocks from the last one to the one we have scanned 50 more blocks forward, it only consists of two transactions. So the more you roll forward, the more you get closer to the latest transaction. Yeah, yes, that's it for now. Yeah, I
Cool.
guess that's what I have.
Nice one, man. That's awesome.
Yeah. Mm,
So, what was the biggest challenge in this? Or was there something that surprised you?
I hope you have understood. Mm, I don't know. It was quite challenging, and also creating the spending transaction as this place and connecting the wallet was quite tricky.
Wait, Paul, can you try speaking closer to the mic?
Oh. Yeah, yeah. Will you now hear me better?
I don't know. I think my signal is unstable as well.
Oh, uh, uh, what
Um,
about now? Could you hear me?
so
Mm.
yeah.
Oh,
So
yeah. Mm,
if I understand this correctly, you've created
yeah,
like a sandbox environment to model the gossiping between nodes in a federated network and the releasing of funds to a particular hub.
yeah,
Is that correct?
yeah. It's just like a sandbox. It does all three, but mostly I was considering it as a backend, mostly the front end, the user interface, but I didn't really so much into it because
Yeah, show me.
I considered
Can you show me
the Prisma,
the back?
the back end of it.
Yeah. Did you say there
Hello?
is or there
Yeah,
isn't?
okay. There is, let me find it for you. I hope you see. It's still the same screen. Let me change the screen. Yeah, it is. Have you seen it?
I'm still on the UI. Ah, yeah, no.
Yeah, it is the basic. Okay, this is
Cool.
the main, the website part, the user interface, the network part, also the
Wait.
now the
Before
chain
you
sync
jump
one.
in, sorry,
Huh?
Paul. Before we jump
Pardon?
into to each file, can you give me a quick overview of the project? Like,
Oh,
um, how how do you hold it all together as one whole?
oh, okay.
How
So,
do you think of it as one
okay, let me.
system? Yeah.
How do I think of it as like one system or what?
Yeah.
Pardon? Oh,
Yeah.
so for me, okay, as one system, I see it like maybe the way they sync together. They should just maybe like a wallet, but not really like a wallet, an enhanced wallet, maybe a better, improved one. That, that sounds something. Let me first show you around on how it looks like. Let me start from the beginning.
Okay.
So first, I called it the RPP. The it is so it's written in Rust, and at first I began with the network part. So this mostly I use Palascript mostly for it. So it connects with Cardano nodes and Mostly for okay for the way it is. Yeah, for the local host for the main one 301 3001 and the other one 302. So these are the two mostly used modes, one for the testnet and the other one for the mainnet. So it differentiates them. Now we go to the other network. Here mostly it's for the chain sync part, the blockchain part for retrieving the chains from the Cardano. So yeah, we have it all and how it syncs. It is syncs the blocks from the chain. It collects them. It fetches them. So I use the block fetch and also the chain sync. Wait, let me show you where. Here's the block fetch. It fetch the block according to the array it has, and also the chain sync is over here. Those are the two. Those are the two backbones of my blockchain fetching, and it's a network part. So we have also the spend. Here it's where I created the spend script transaction. It contains a script hash index, a scriptable of the beneficiaries, but let's say half of them are solved by the wallet for the calling of the wallet and popping out of it. Here it is. Here it's just the testing of it.
Okay.
And yeah, it's the where we now submit the transaction that we created. We submit this in this file now with a submission. With this call, we append this menu protocol transaction submission. It submits it to the blockchain main, the on-chain one. So it's also, yeah, it is you connect and then you build the transaction. It's a Conway because we're in the era, the seventh era, and it is you call just similar. Mostly the chain sync, the block fetch, and the transaction submission. Their mini protocols are the pillars create. Now we go utility. I was creating functions that could help me just call other things when writing. Maybe the unwrapped script, the pass, the decoding. They were just functions for helping me around to move around. And we have the web. I had two of them, and is an update of the other. It's actually run with mostly the Axon part of the Rust. Yeah, the full one. It's just calling the user interface of it. It also contains the HTML part and the Java. It is on the C++. So now the web will look like. That's the bigger part. Let's show you also the smart contract part.
Okay.
Let me find it first. Are you seeing my screen?
Yeah.
Oh yeah, because on top of it, it just me.
How long did this take?
Around, let's say 3 weeks. 3 weeks, let's say around maybe 2.5, maybe 3 weeks.
Wow.
Yeah,
Wow.
but my best part was the smart contract part. It's really interesting creating a smart contract. So, let's say maybe it's my best part. Yeah. So it isn't yet loaded. Okay, it is. Mm-hmm. Yeah, using it now. Could you see my screen now?
Yeah. Yeah.
Oh yeah. So I So this is where I create my smart contract. So I called it the PPP. The other one was RPP. I guess I named them simple words so that I couldn't forget them. So first we could go to mostly I place them as a validator. And here it is. It's written in ICANN. ICANN is an aggregate of Rust. So here it is. Not that colorful. So it's just a shorter one so that we call out the crates that we need, the ICANN, the Cardano. So here it is. When we first called out the data. This data is similar to what was called as a spend transaction. It's what the spend should have for it to be accepted by the contract. So it has a data and a redeemer. So this is just a function for valid signatures. So we now create the validator where we call spending. It should also have a minting part here too. So we start with the spend part. We call the data redeemer reference output. It refers to the unused output reference that we used for calling for the spending transaction to use. So here, when the datum is none, it fails. But we now create the P and the D. It is, and this is where I called the P and D should add up to 10. So for the adder to come out, the user at the hub during when submitting transaction, they should make sure that the P and the D should equal the contract, P and D should equal to 10. It should also have a valid hub and it should contain is for verification first for the spending. It should have a valid score. Here it is, which should be equal to 10 PND and a valid hub public hash. Here it is a byte array of this length should be equal to 28. If not fails, the 1 point adder is released is the part for the is also a redeemer, a police AD, and a so we used the action. When after minting it should burn, the coin should go away, but not remain there. Yeah, I guess that's it. So after running it, it compiles into a Plato JSON. It is which later converts to a script address that later on one locks adder by sending some adder to it. Yeah, that's my icon project too. Hello.
Hello.
Yeah, guess I'm done with presenting.
What does the Plutus JSON do?
It's after having it, it's later converted to a script address. After this after conversion, it becomes a script address.
Yeah.
The script address can later on send some adder to it where it's locked there until the
Yeah.
redeemer is satisfied.
Yeah. Okay.
Mm. Niche find.
Okay, really cool, really cool. Wow.
That's what I have for today.
This
That's what
is
I had for you.
yeah. I I feel very grateful that you've put all of the time into experimenting with this.
Yeah. Thank
Um, yeah, this is cool. How
yeah.
does how how does the gossip function relate with the
The gossip.
spending or the funding release? Are they connected somehow, or you were just kind of like experimenting with two different parts?
I was experimenting with two different parts, but I later merged them. Okay, I merged them at the point and they signed everything, everything here after being signed. It's later on just added over here. You see a central transaction to broadcast, which later on broadcasts to the apps around. Clearly,
Yeah,
yeah. So let's say the hub's connection after every hub is added as a let's say
yeah,
added to this project, it just shows up over here. It's
yeah.
over here.
Oh, I
Or
see.
maybe if you yeah, or maybe if you have the address of the hub, you could just write it over here and connect.
Wow, this is really cool, man.
Yeah,
But then does it assume that the hubs are running a node?
it does assume that too. I also
I suppose
adjusted
it could be in a cloud environment. It doesn't
yeah,
necessarily need to be
in a cloud.
on on-prem. Yeah. Okay, cool, cool.
Mm.
Um, yeah, this is great, man. I think
Mm.
um I'm trying to think because I I didn't expect you to literally spend 3 weeks building out a a proof of concept. Um, I know this is very early stage still, right? Like
Yeah, the lower
it's
part, lower end.
how okay, I'm trying to think of what questions to ask you even. How about have you worked because you mentioned you've worked on a protocol before, right?
Uh, at the okay, not that. Let's say only the early parts, well, early stages of it, not that
Okay, okay, yeah. So I was
far.
gonna say,
Mm.
okay, that's fine. I was trying to think about how do we develop it from here? How do you want to develop it from here? What do you see are some of the next steps, and how does it connect to the big picture?
So the next steps that I was thinking about mostly it was at the contribution score part,
Yeah,
the P's and the demand, the participation. Let me call them the P and the D. So the P because they're in a graph form, maybe they could be converted into an integer, and that integer carries a commitment. So during the gossip, during the gossip period, if the other hub receives a message, it will only show the integer and the hashed commitment, the hash commitment message. So this will actually promote sovereignty, I guess.
This is interesting.
Yeah.
Wait, say that last bit again.
Yeah. The P, they could be, it only carries the integer and a
Yeah,
commitment message. The commitment message is a hashed, because the P's I noticed there are maybe voice notes, videos, so maybe they could be
yeah.
hashed. So the P carries the hash form of them and sends
Oh, I
them. So
see.
the other half, the other half couldn't read what you did, but could see you did it. So it's maybe let's say the zero knowledge.
Yeah.
Yeah, that's my next step, I guess. Yeah.
Okay, and how does it connect to the big picture?
I guess it really plays a big part of the sovereignty part to ensure that maybe hub A could choose or not could be seen by hub B, but not hub B to actually see everything that hub A has done. Privacy, privacy.
Yeah. Um, Interesting. So you're thinking of primitives being like digital assets that are stored in the
Yeah,
wallets of the hubs?
yeah.
Okay. Um, okay. Okay. Cool. Okay. All right. Great. So I think, uh, yeah, I mean, okay. And what aspect of this whole project have you enjoyed the most? Did you enjoy the details of the actual implementation level work or the the concepts and the thinking at the design level, um, or the learning about new stuff? Is there any part of it that you enjoyed the most that you would say is your favorite aspect of that work?
I did have some stages where I felt really happy when doing them. Mostly the building part where I came out with the ideas of how I would structure it, and also the results. Seeing the results also was my best part. I felt really good, but also coming up with the structure, learning mistakes too. Uh, Yeah,
Yeah,
the best part mostly was the building part,
the
coming
building.
with the concepts on how things will go. Yeah.
Okay. Okay, cool. Cool. So I have an idea of your profile, and
Yeah.
if we're able to bring anyone on board for when we're ready to build this, I will reach out.
Okay. Okay.
What
That's great.
do you have any questions for me? Anything you want me to be aware of?
Mm, The the yeah
What are
the
your
demand
aims? What are your, okay, yeah, go for it.
the demand because maybe it's the external part where we the data received is external, and because I also saw that you wrote due to currency differences, it could be maybe it could maybe be a problem collecting it. Maybe I was thinking if we could have something that really adds up to one, maybe something that integrates into one. Maybe I was considering a reference. The currencies could be reference to the current other equation to a dollar, I guess, equality to a dollar. That's what I was thinking. Or
Yeah.
how, how, how what was the other, what lots did you have of the demand ideas? But,
Yeah. Okay.
mm,
Cool. What's what are your aims with developing this? The whole project, not the demand thing
mm,
in particular.
yeah, yeah, yeah. First of all, it's growth. First, it, it helps me to grow. So it's also challenging. Okay, it helps me grow due to these challenges. Maybe after doing after stepping every different step, I feel challenged, which makes me grow. And also, because
Yeah.
Prisma is also at the beginning stage, I also want to
Yeah.
partake or also participate into maybe something that will become great in the future part. Uh,
Yeah, yeah, yeah.
uh, also
Okay, cool.
exposure.
Yeah. Great.
Uh,
Great. Okay. Excellent. Well, I hope that we can find a way to bring you on board for some more work.
uh,
For now, I will need to we'll need to wait and see what comes from some of these proposals that we're making.
oh,
And yeah, I hope that I'll be able to reach out in the future.
uh, I'll be available anytime, any moment.
Cool. Great. Okay, then thank you very much again, Paul. This is really very generous of you to make this. And yeah, I think it's sending a really strong signal that you want to grow, like you say, and you're interested in this work, which is uh I really appreciate that. So I will definitely be bearing you in mind for if we can bring on some developers in the future. I will let you know.
Thank you. And also thank you for help to giving me the chance to also showcase my work.
Of course.
Yeah,
All right, man. Then
mm,
yeah, have a good rest of your week and we'll be in touch.
okay, same. Also have an interesting week.
Okay. Take care.
Same, same. Take care. Take care.
See you. Bye bye.